Okay, today we're going to go over quiz 3 that you took the other day. And it was a quiz that had everything that we dealt with so far with integers. Okay, it started with additive inverse, the opposite, absolute value, the distance away from zero, always positive, and comparing integers by thinking of positive as having, negative as owing, and the one you'd rather is always larger. Then we went into adding integers, which means same signs, add and bring down the sign. Different signs, subtract and take the sign on larger, even though it's addition. Subtraction, change subtraction to addition by changing the number you subtract by to its opposite. And then follow the addition rule, which means sometimes when you subtract, you change it to addition and you add. But sometimes it seems kind of weird, but when you subtract, you change it to addition and you still subtract, because you follow the addition rule, and if you have different signs, you're going to subtract. And finally, multiplying and dividing, where in multiplication you always multiply, in division you always divide, but the sign changes. If you have the same sign, your answer is positive. If you have different signs, your answer is negative. Anyway, these are the answers on the quiz you took. Number 1 was a positive 6, number 2 was a positive 8, number 3 was a negative 4. By the way, there was no number 4. Russell was the first one to turn it in, and he informed me right away. But I did skip number 4. I'm only a math teacher. You expect me to know how to count. Anyway, it went to number 5, a positive 182. Number 6, which was really the fifth problem, a negative 881. Number 7, a positive 334. Number 8, a positive 406. Number 9, a negative 3,741. Number 10, a positive 7,678. Number 11, a positive 130 and 1/4, or a positive 130 and 25/100. By the way, I told you the last time that you could not write your remainder as a decimal. You had to write your remainder as a fraction. I said that if the problem kept going on. In this case, 1/4 is 25/100, so it doesn't keep going on. So you don't need to write it as a fraction if you don't want. You could write it as a decimal. Personally, I think it's easier to write it as a fraction. That's just my opinion. And then the last one, number 12, which was really only the 11th problem, a negative 123 and 5/69. And that one you could not write as a decimal because it keeps going on and on and on and on. And you say, but Mr. Dew, when I used my calculator, it stopped after 6 places. First of all, you're not supposed to be using your calculator. And second of all, even if it did go 6 places on the calculator, that means the calculator rounded to the 6th place. But you can't round unless it's money or unless you're told to. So writing as a fraction was the easiest way. Anyway, to go through them now real quickly, number 1 says find the additive inverse of a negative 6. Again, the other word for additive inverse is the opposite. Okay, inverse does mean to turn around or do the opposite. And the additive inverse of a negative 6 would be a positive 6. And please notice it does not say equals a positive 6, because there's no way a negative 6 equals a positive 6. The arrow says it changes into a positive 6. Okay, and again, additive inverse is the opposite. The next one, number 2, said the absolute value of a positive 8. Absolute value is the distance away from 0. Distance can never be negative. Therefore, absolute value must always be positive. So the absolute value of a positive 8 is still a positive 8. So additive inverse, you change to the opposite sign. Absolute value, you make it positive. If it's already positive, you leave it the same. If it's a negative and you give the absolute value, you make it a positive. And finally, which is larger? Again, to compare a negative 13 or a negative 4, think of positive as having, negative as owing, and the one you rather would always be the largest. So ask yourself, what would you rather? Owe $13 or owe $4? By the way, I'd rather not owe anything. But if I had to choose between owing 13 or owing 4, I'd rather owe $4. Therefore, a negative 4 would be the answer to the one that's larger. And again, if you don't want to use positive as having, negative as owing, think about which one is further to the right, because if you think of a number line, doesn't the numbers get bigger as you go to the right? And again, a negative 13 and a negative 4 on a number line, a negative 4 is further to the right. So anyway, that was the easy part in the beginning, additive, inverse, absolute value, and comparing integers. Then we start working with them. Now again, in addition, the first one says a negative 137 plus a positive 319. And again, you ask yourself, same signs or different signs? And I have different signs, so the answer is subtract and take the sign a larger amount. But I can't subtract 319 from 137 because 319 is larger. So I use the commutative property of addition, which is an addition problem. Even though I'm subtracting in it, it's an addition problem, so I can change the order. And then I can subtract, and when I subtract, I get an answer of 182. And then I take the sign of a larger amount. The larger amount is on the top, it's a positive, so my answer is a positive 182. By the way, a lot of you just put 182 and didn't put any sign, and you got it right, because no sign means positive. But again, it is a positive 182. The next addition problem said a negative 388 plus a negative 493. Again, the first thing you ask yourself is same signs or different signs. I have the same signs, therefore I add and bring down the sign. 8 and 3 is 11, carry you 1. 1 and 8 is 9, and 9 is 18, carry you 1. 1 and 3 is 4, and 4 is 8. And then you bring down negative plus negative, you add and bring down a negative sign. By the way, you might say, I thought same signs answer positive. That's multiplication and division, not addition. In addition, a negative plus a negative is a negative because you bring down the negative sign. Adding is not the same as multiplying. Don't get them mixed up. Then we go to subtraction, which is still the thing that most of you are having the most trouble with. And that's not surprising. Every year, this is what people struggle with the most. And the reason they struggle with it is they don't follow the rule. They don't do what the rule says to do. So if I had a negative 233 minus a negative 567, again, the rule for subtraction says change the subtraction problem to an addition problem. But you don't just add, you don't just make it addition. The only way you can change subtraction to addition is if you change the number you subtract by on the bottom or in the back, by, bottom, back, change it to its opposite. So a negative 233 minus a negative 567 becomes a negative 233 plus a positive 567. And again, subtraction becomes addition, and the negative 567 becomes a positive. Change subtraction to addition by changing the bottom number you subtract by to its opposite. Now that I changed it to an addition problem, I follow the addition rule. That does not mean add, it means follow the addition rule, which means now you have to ask same signs or different signs. This time I have different signs, so I subtract. I cannot take 567 away from 233, so I use the commutative property of addition because it's an addition problem now. I can put the positive 567 on the top, the negative 233 on the bottom. I can subtract like normal. 7 minus 3 is 4, 6 minus 3 is 3, and 5 minus 2 is 3. And then I take the sign of a larger amount. The larger amount is positive, so my answer is a positive 334. And again, if you didn't put any sign on it, you got it right, because no sign means positive. The other subtraction problem said a positive 143 minus a negative 263. Again, the first step is change subtraction to addition. And it's not magic. You don't just say poof, you're adding. You change subtraction to addition by changing the number you subtract by to its opposite. So minus a negative becomes plus a positive. By the way, you don't do anything to the top one, only the one you subtract by on the bottom. Now you ask, do you have the same signs or different signs? Now I have same signs, So I add and bring down the sign. 3 plus 3 is 6. 4 plus 6 is 10, carry your 1. 1 plus 1 is 2, plus 2 is 4. And again, no sign means positive. So if you didn't put a sign, you got it right. So again, what a lot of you skip in subtraction is you don't make it addition first. You try to do it as a subtraction problem. You're going to get it wrong every time. Not every time, but most times. Change the problem to an addition problem and go back to what we did with addition. Different signs, subtract and take the sign of larger, same signs, add and bring in a sign. Once you make it addition, but you don't just make it addition, you have to change the number you're subtracting to its opposite. Next thing we had was multiplying. In a way, that's a lot easier because you always multiply. In a way, it's a lot harder because you have to make sure you multiply correctly. So if I was to multiply 43 times 87, 21 carry your 2, 30, put a 0 here, 24 carry your 2, 32 and 2 is 34, add 1, 4, 7, 3, you get 3,741, and a negative times a positive, different signs, answer negative. Or if you want to use the other rule, if you hate to love, then you're going to hate. And again, the answer is a negative 3,741. It's harder to multiply than it is to get the sign right. But you need to not get your rules confused, because some people say this answer should be positive because this is a larger amount. That's not the multiplication rule, that's the addition rule. The multiplication rule says different signs answer negative. Now, the other multiplication said a negative 349 times a negative 22. Again, always multiply. Again, make sure you don't make a careless mistake. Excuse me. 2 times 9 is 18, carry your 1. 2 times 4 is 8, and 1 is 9. 2 times 3 is 6. Put a 0 here. 2 times 9 is 18, carry your 1. 2 times 4 is 8, and 1 is 9. 2 times 3 is 6. Then if I add 8, 9 and 8 is 17, carry your 1. 1 and 6 is 7, and 9 is 16, carry your 1. 1 and 6 is 7, and again, your answer is 7,678, but you got to figure out the right sign. You have same signs, so your answer is positive. Same signs answer positive. So a negative times a negative is a positive. Earlier, a negative plus a negative is a negative. Don't mix the rules up. By the way, excuse me, again, you have to make sure you multiply right. No sign would make that positive. Then we go to division. Still in division, you always divide. And again, you can, make your remainder a fraction or a decimal. But if the decimal goes on, you got to keep going until it ends. So it's smarter to make your remainder into a fraction. Anyway, the first problem said a negative 4,168 divided by a negative 32. Again, divide like normal, 32 into 4,168. Divide 3 into 4 goes once, shift back one place. 1 times 2 is 2, 1 times 3 is 3. Subtract by borrowing, 11 minus 2 is 9. Bring down your 6. 3 goes into 9 3 times. 3 times 2 is 6. 3 times 3 is 9. Remainder 0. Bring down your 8. 32 is bigger than 8, so it goes 0 times. Remainder 8. And now you got to make your remainder either a fraction or a decimal. I think it's smarter to make it into a fraction. Write 8 over 32, because the divisor is 32, and then simplify. What goes into 8 and 32? How about 8? 8 goes into 8 once, 8 goes into 34 times, and that's how you get your remainder of 130 1/4. Now, if you really want to make it a decimal, you can, but it's a lot more work because you have to add a decimal and a 0, bring the 0 down. 3 goes into 8 2 times, 2 times 2 is 4, 2 times 3 is 6, remainder 16. Add another 0, bring it down. 3 goes into 16 5 times. 5 times 2 is 10, carry 1. 5 times 3 is 15, and 1 is 16, remainder 0. So you could get this one as a decimal because you get a remainder of 0 after dividing and adding 2 extra places. And again, if you want to make it a decimal, I will give you credit for it. But if you're going to make it a decimal and round it, I will not. Because the only time you can round is if I tell you to, or if it's money. And I didn't tell you to round, and this is not money. But that one was okay. This next one is not if you decide to make it a decimal. Anyway, it's 8,492 positive divided by a negative 69. By the way, I skimmed over the sign on the other one. It was the same signs, that's why the answer was positive. Okay? And again, if you hate to hate, you're not going to hate, you're going to love. So a negative divided by a negative is a positive. Anyway, here, first thing I do is divide 69 into 8,492. 6 goes into 8 once, shift back 1 place. 1 times 9 is 9, 1 times 6 is 6. Subtract by borrowing, and your answer comes out to be 15. Bring down to 9. 6 goes into 15 2 times. 2 times 9 is 18, carry your 1. 2 times 6 is 12, and 1 is 13. I can subtract. 9 minus 8 is 1. 5 minus 3 is 2. Bring down to 2. Divide 6 into 21 goes 3 times. 3 times 9 is 27, carry your 2. 3 times 6 is 18, and 2 is 20. Borrow, and you get a remainder of 5 69s. And this is definitely one where you do not want to make it a decimal, because I would go all the way down the board and up and again dividing before it finally repeats, and it's never going to end. Anyway, that's my answer, but I got to figure out the sign. A positive divided by a negative, different signs answer negative. And again, don't forget the sign. Matter of fact, some people put the sign for the answer before they even do the work, so they won't forget it. But then they put the sign for the answer before they do the work, but then they forget to put it in front of the answer. So don't forget to put it. But anyway, different signs answer negative. And again, if you love to hate, then you're going to hate. Or you can just say different signs answer negative. And again, that goes through everything we've learned about integers so far. All right, and again, excuse me, you're going to take one more quiz 4 before we're going to put them together as a group. But things are going to change because we're not going back to school, it doesn't look like, so I'm not going to be able to collect your corrections. So I'll be explaining to your parents, I'll be explaining to you soon how we're going to work it with your quizzes, because we're going to take 5 quizzes and go from there. But anyway, I hope everyone who was having trouble, and some of you are having a lot of trouble, I hope you understand what you did wrong. And the thing you did wrong the most is in subtraction, you did not make it into addition by changing the number you subtract by to its opposite. And just because you make it addition does not mean you add, it means you follow the addition rule. Subtraction is the one that causes the most trouble, so therefore it's the most important one for you to know how to do. All right, good luck on your corrections.